Hi everyone, let's start chapters 7 and 8. In these two chapters, we will have random numbers and random variates. So section 1 from chapter 7 will be covered in this week, and this is the first part of the pre-recorded videos. So on our course map, we just finished chapter 6, queuing models. So now we are going to have chapters 7 and 8. As you remember in the simulation models that we had in chapters 2 and 3, generating random numbers and random variates are the core component of any simulation model, right? Because without generating random number or without generating random variables or random variates, we can't run the simulation models, right? So in these two chapters, we're going to see what are the concerns about the random number generators and how we can generate random numbers and random variates from uh, particular distributions. Okay, so let's start. So as you remember, a random number is any randomly generated number between 0 to 1, right? And again, as you remember, without this element, we cannot run a simulation model. As you remember in Excel, we had this element because without this, we couldn't generate a random variable from a specific distribution, right? So generating random number is a necessary part for any simulation model. And we know that the packages like Arena have subroutines or modules or functions to generate random numbers. Even Excel does have it. Yeah, in Excel we have the rand function, and this function generates a random number, right? So you may ask now, so why we are going to learn in this chapter some methods to generate a random number, because these tools like Excel, Arena, these tools do generate the random numbers, right? But in this chapter, we'll see what are the properties of a good random generator method. And then we may test actually the rand function in Excel to see if it's working well. And you may find that it's not. So you may decide to actually code your own random generator method for a specific purpose in a simulation model. Okay, so yeah, in this chapter, I'm in chapter 7, we will learn some methods to generate random numbers, and also uh, the test method that we can test if that random generator method working well. And in chapter 8, we will learn the methods to generate random variates or random variables from particular distributions. Okay. In any simulation model, we generate a sequence of random numbers and then use these random numbers in the runs, right? So the properties that we need to have for a sequence of random numbers uh, are uniformity and independence. Okay, so without these two properties, we can't trust that random number generator method. So let's see what are these two properties. The uniformity property says that the random numbers generated by a random number generator method should uniformly distributed in the range of 0 to 1. Okay, and the independence property says that if we have a sequence of random numbers R1, R2, so these numbers should be independent to each other. So in order to understand that what these two properties say to us, let's consider the uniform distribution here. As you remember, the uniform distribution over the range of 0 to 1 has this PDF function, and its expected value is half, and the variance is 1/12, and this is the PDF shape actually. Okay, so so let's say, for example, we are using the rand function in Excel, and we are generating, let's say, 1,000 random numbers. Okay, then if we draw a histogram by having 10 bins, if we segment 0 to 1 into 10 segments, 0.1, then 0.2, 0.3, and so on, okay, up to 1. Then we should see almost this shape for the histogram of the 1,000 numbers, like this. Yeah, like this. Yeah, we don't expect actually to have exactly uniform because it's just 1,000 numbers. If we generate infinite numbers, then yes, we expect to see exactly the uniform distribution. But by having a limited numbers like 1,000 numbers, we expect to see something like this. Okay, but if we observe that the histogram is like this, for example, for in this segment we are here, and then the next segment is like this, and then that. Yeah, by having this kind of behavior, we can't say that the uniformity distribution holds on that method because it's not uniform for sure by having this kind of behavior. So we can test actually visually. I can visually. We have test methods in these chapters. In this chapter, we will have it. But now, visually, actually, we can test if that random number general method works well. Okay. And for the independence, let's say we have generated again 1,000 numbers. If, for example, the first 10 random numbers are in the interval of 0 to, let's say, 0.4, for example, I mean, all the 10 numbers are here, okay? Then this shouldn't impact on the generating the next 10 random numbers to be in the higher levels, I mean, over 0.4 up to, let's say, 1, okay? Or if, for example, the last number is 0.99, then shouldn't impact on the next number to be for example 0.10 or 0.12, for example, I mean a low number. So yeah, I mean independence says that there shouldn't be any relationship between the sequence of the numbers that we generate by that random number generator method. Okay, and again we have a test method to test that if that random number generator method has the property of the independence. Okay, so we'll see these test methods in chapter 7. Okay, this was the first part of the video. In the second part, we will see two random number generator methods. Okay, thank you.